we're just going to be extending from what we were doing yesterday. Okay, so not much more than what we saw yesterday. Give me a second here. I may go ahead and put all this on a separate sheet of paper just so I can make sure I have all the room to show you the things here. So this is all we're doing. We're just doing these problems 1 through 21. So I think our classwork today is just trying to get through this page. Okay, so it should be a short period today as well. Now, number 1. So this is a little bit more involved. Two-step process. We always want to start on the inside portion. Okay, so inside portion, we're just going to ask ourselves this question. What will it look like if I had cosine of theta equal to root 3 over 2? So that's just another way of saying it. Anytime I see arc cosine or inverse cosine, just think of it as, if you want to write it in a more straightforward way, cosine of theta is equal to root 3 over 2. Okay. Now, from this information, we're going to create a triangle in the correct quadrant. So cosine is positive. Which quadrant are we going to be in? All right, first, right? So cosine is first and second. Sine is fourth and first. Tangent is fourth and first. So based off of this, we're going to create a triangle. And once we create a triangle, we'll find the sine of the angle. Okay. So first quadrant. Cosine of theta is equal to root 3 over 2. This is SOHCAHTOA, adjacent over hypotenuse. Pythagorean Theorem, a squared plus b squared equals c squared. Now, some of this, you're going to feel like we're overdoing it because it's going to live on the inner circle, but I think this is a good habit to build, especially later on when we're dealing with variables where it's not going to be as clean. But if you go through this process every time, we should be able to have a nice way of approaching these types of problems. Okay, Pythagorean Theorem, a squared plus b squared equals c squared. Three plus b squared equals 4. B squared equals, I'm sorry, root 3 squared. That's just going to be 3. 4 minus 3 is 1. B squared is 1, so b equals 1. First quadrant, everything is positive. So therefore, sine of theta is going to be what? 1 over 2, 1/2. Okay, so that's how we're going to be approaching our problems for a lot of this. We're going to figure out the triangle from the inside portion. Once that's established, then we move on to the outside. Okay, number 2. Cosine of arctangent of 0. So rewrite that inside portion. This is another way of saying what would it look like if tangent of theta is equal to 0? So where's tangent equal to 0? At this point, right? Tangent of theta is equal to 0 at when theta is 0, 0 over 1. So what's the cosine here then? Just 1, right? Does that make sense? So here we didn't have to draw a triangle because it was living on one of the axes. Okay, let's try 3. Looks a little messy here. This is 2 times inverse cosine of negative 1/2. Okay, let's just focus on this portion here. This is saying, where is cosine of theta going to be equal to negative 1/2? Cosine is negative where? Principal value, so where do we look? Second quadrant, okay. Where is cosine equal to negative 1/2? 2 pi over 3. So in other words, is tangent of two times 2 pi over 3. Okay, so tangent of 4 pi over 3. Refer back to our unit circle. Tangent of 4 pi over 3. Negative root 3 over negative 1, which is root 3. All right, number 4. We always want to deal with the inside portion first. So let's figure out what sine of pi over 3 is. All right, unit circle, what's sine of pi over 3? Okay, root 3 over 2. So we'll go ahead and replace this with root 3 over 2. So now we'll say arc sine of root 3 over 2. We're going to go back to where we came from, right? This is basically saying when is sine of theta equal to root 3 over 2, that's going to go back to where we just started, right? Pi over 3. So that goes to show you that when you're doing arc sine of sine or arc cosine of cosine, if you're pairing two inverses on top of one another, you're going to be left with that initial angle measure. But sometimes things can be a little tricky when things don't line up in the correct quadrants. So let's look at number 5. Two-step process, always start with what's inside the parentheses, and then we can move outwards. What's cosine of 3 pi over 2? Okay, 0. So now, inverse cosine of 0. So in other words, this is saying when is cosine of theta equal to 0? So now we're forced to just look at the first and second quadrant. Where's cosine equal to 0? Pi over 2. So even though this is starting at 3 pi over 2, once we're back in terms of principal values, we have to look in the first and second quadrant. So pi over 2. All right, number 6. First things first, start with what's inside the parentheses. What is tangent of 11 pi over 6? Negative 1 over 3, right? Okay. So let's rewrite this. Arc tangent of negative 1 over root 3. So in other words, when is tangent of theta equal to negative 1 over root 3? So now that we are dealing with principal values, tangent, we have to look in either the first or fourth quadrant, but we have to learn to make an adjustment, right? Maybe we're thinking that we can go to 11 pi over 6, but now that we're dealing with principal values, we need to make an adjustment. Theta is now going to be negative pi over 6. Are we good there? All right, number 7. Start inside first, figure out what cosine of 2 pi over 3 is. Negative 1/2, right? Shifting over to sine, we're going to ask ourselves, when is sine of theta equal to negative 1/2? Remember, sine is first and fourth quadrant, principal values. Where's sine equal to negative 1/2? Yeah, negative pi over 6. Mm-hmm. Okay, number 8. Start with what's inside the parentheses. Tangent of 5 pi over 4. Tangent is y over x. We go to the third quadrant. What's that going to be? 1. So now let's rewrite our problem. Where is cosine going to be equal to 1? In other words, where is cosine of theta equal to 1? Yeah, 0. Yes?
Doing an arctan like pi.
All right, looking at number 9. Yeah, I'll go over that with you. Okay, so cosine of theta equals 1, theta must be equal to 0. Okay, number 9. Arctangent of sine of 7 pi. Sine of 7 pi, that's the same thing as what? As pi, right? It's just going to keep, it's like an odd, it's going to keep recycling every 2 pi. So basically, what's sine of pi then going to be? 0. So we can turn around and say, well, what is arctangent of 0? In other words, when is tangent of theta going to be 0? When theta is zero, right? Tangent of theta is going to be 0 at y over x, 0 over 1, 0. Okay, so now we're going to be dealing with values that are not on the unit circle, but we can still work our way from a triangle perspective. So let's look at number 10 here. Sine of arctan of 4/3. Okay, not a unit circle value, but we can create this scenario. We know the inside. This means tangent of theta equals 4/3. We can build this value. So triangle, tangent positive in the first quadrant. Opposite over adjacent. Pythagorean Theorem. A squared plus b squared equals c squared. We can recognize this as a 3, 4, 5 triangle. But now we can turn around and say, what is sine of theta equal to? 4 or 5. All right, 11. Create a triangle. We know that sine of theta is equal to 24 over 25. Sine is positive. We know that's first quadrant. Opposite over hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. It's going to clean up to be 49. Take the square root. We get a equals 7. So now that we filled in the triangle, we can figure out what cosine of theta is. Cosine of theta is 7 over 25. Good so far? All right, number 12. Yes.
So for number 11, the sine of 1. So what is the hypotenuse be for?
Okay, this is not the same thing as cosecant. This is inverse sine. So that's something else. So when you see this inverse notation, this is really saying sine of theta equals 24 over 25. But it's basically getting that theta by itself, so it's doing inverse. So don't think of inverse as reciprocal. It's something different. Okay, it's just representing something where theta is by itself instead of the coefficient, instead of the ratio. Okay, number 12. Start with the inside. Let's build that information here. Cosine of theta is equal to -8/17. Okay, where's that triangle going to live? Cosine of theta equals -8/17. Good. Cosine is first and second quadrant. -8, that's adjacent. 17. All right, Pythagorean theorem. Work that out. It's going to be 225. B is 15. All the hard work is done. Now we should figure out tangent of theta. What's tangent? (15/(-8), right? Okay. I'm sorry, tangent of theta equals. All right, 13. Inverse tangent of -2/3. Thank you. Understand this is saying, another way of saying this is tangent of theta is equal to -2/3. From here, we'll build our triangle. Where's this going to live? Good, fourth. Sine and tangent negatives will be in the fourth quadrant. Cosine negative will be in the second quadrant. Opposite over adjacent. Pythagorean theorem. A squared plus b squared equals c squared. Square roots. All the hard work is done. Now we can just figure out what cosine of theta is. What's cosine going to be? Yeah, 3/13.
Do we have to rationalize?
Either way. Yeah, either way is fine. Number 14. In other words, this is saying when is sine of theta equal to -1/4? It's not a value that lives on the unit circle, but we can build this. Which quadrant? Sine is negative, so where do we look? We're fourth quadrant. Opposite over hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. (16 minus 1 is 15). Cotangent of theta is adjacent over opposite, x over y. Okay, let's see what this inside is telling us. Cosine of theta is equal to 2. Cosine going to be 2. Think about cosine and what cosine graph looks like. Yeah, it only goes up to 1 and -1, right? So it's never going to hover, it's never going to drop below -1 and or above 1. So it's not going to happen, right? So if it can't happen, then we can't figure what that value is. It's undefined. Okay, let's talk about what happens when there's an x in your ratio. Okay, we're still going to go through a triangle. It's just, and still go through a triangle, still going through the Pythagorean theorem. We're just going to have variables left in our answer. It's okay so far? Right? 16. Same process. We're going to start in the middle, inside the parentheses. This is saying tangent of theta is equal to x over 1. First quadrant. I put x over 1 so I can see the numerator denominator. Where does the x go and where does the 1 go? Opposite. 1 is Jason. Okay, feels kind of strange, right? Having an x there. Yes. You look at the sign. If it's negative, then we want it in the fourth quadrant. Yeah. So sine and tangent negatives are in this fourth quadrant. Cosine negatives will be in the second quadrant. A squared plus b squared equals c squared. So it's kind of strange, right? I got to do 1 plus x squared equals c squared. That x squared is not going to go away. So your hypotenuse is going to look like this, square roots. And just keep it positive here. Okay, so that's something new and different, right? Are we okay with why that hypotenuse looks the way it does? Okay. What's sine of theta going to be? Yeah. And I would say here, don't worry about rationalizing the denominator. We just write it out whatever way they have it. So same process, just a little messier because the x is just not going to go away. That variable is going to play a role in our answer. Okay, 17. In other words, when is cosine of theta equal to 2x over 7? Cosine is positive. First quadrant. All right, where does the 2x and where does the 7 go? And then over sine. A squared plus B squared equals C squared. Careful, when you square this, is it 2x squared? Square both, becomes 4x squared. Okay. Thank you. That's fine. Yeah. Okay. Tangent. So tangent is just going to be opposite over adjacent. So just put them over each other and we're done. Opposite over adjacent. Okay, finish this off here, number 18. Yeah, pretty much all of this is going to be in the first quadrant here. Inverse sine of square root of 11 over 3x. In other words, asking ourselves, what would it look like if the sine of theta is equal to root 11 over 3x? Draw your triangle. Opposite over hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. All right, what's cosine of theta going to be? Yeah, adjacent over hypotenuse. Okay, last few here. Can you guys try them on your own and we can compare answers? 19 through 21. All right, check my answers as well. See if you got the same thing I did. All right, pretty much all of these are in the first quadrant. Build your triangle, identify your trig ratio, Pythagorean theorem to get that missing side, and then turn around and do the outside ratio. Are we okay? Yeah.
Wait, so for number 19, didn't you just reduce it because all of them are different squares?
Yeah, but the issue is that this minus throws a wrench into our process. If it was x squared times 16, then yes, we can clean all that up. But that minus forces us to just have to leave it alone. Yeah. Okay, let me just check this page. Just understand that whenever you see this or write it this way, tomorrow we're just reviewing, no new material, which is gonna bring back what we did yesterday as well, and just get some more practice in.